Welcome to the second part of 7th module, Static Code Analysis with Sonarqube. So in the previous part of this 7th module, that's part 1 of 7th module, we looked at how to test the functionality of an API with Postman, and we have looked into the Postman in totality. A Postman is a free tool for working with API and for testing APIs. And also we have looked into the integration and automation of these tests in a CI/CD pipeline using Newman. So we have discussed about that. Then, testing the functionality of an API or application is good practice when we wish to improve the quality of applications. In a company, the quality of an application must be considered by all its members because an application that brings business value to users increases the company's profits. However, we often neglect to test the quality of the code because we think that what matters is how the application works and not how it is coded. So this way of thinking is a big mistake because poorly written code can contain security vulnerabilities and can also cause performance problems. Moreover, the quality of the code has an impact on its maintenance and scalability because code that is too complex or poorly written is difficult to maintain and therefore will cost more for the company to fix it, to maintain it. In this part of 7th module, we will focus on static code analysis with a well-known tool called Sonarqube. We will provide a brief overview of it and we will go over and we will install the Sonarqube. Then we will use SonarLint to analyze the code locally, and finally we will integrate Sonarqube into a CI/CD pipeline using Jenkins and Amazon Web Services. We will do that in our mega project. I'll show you how to do that. So we will have one project of Sonarqube. So that we will do. In addition to that, Sonarqube will be used in our mega projects also. So, but the question arises, what is Sonarqube? Sonarqube is a self-managed automatic code review tool that systematically helps you deliver clean code. So clean code is pretty important. That if you provide a clean code to the system, so the system can understand the code better than that the code with a lot of scrap, lot of nonsense inside the lines, in between the lines, in between the lines there, if you keep a lot of spaces, so this is like you're complicating the things around. If you complicate the things around, the machine has to spend more amount of time, and after that, even if you want to debug it, if you want to solve some problem, if you want to find an issue, if you want to maintain it, it's gonna take huge amount of resources. It could be money, or it could be time, or it could be man force. So a clean code is very important. As a core element of this Sonar solution, Sonarqube integrates into your existing workflow and detects issues in your code to help you perform continuous code inspections of your project. So we are going to do one project in this. So that project is, so we will be adding this Sonarqube into the continuous integration pipeline. So as every time the code is being pushed into the repository, and then the pipeline will be triggered. Once the pipeline will be triggered, our Sonarqube comes into the picture and it will automatically do the analysis, code analysis. And once the code analysis is done, it will show you the errors, how many bugs are there, how many errors are there, and how many issues it has found. So everything it will show, how many vulnerabilities are found. So it will show everything. So that kind of project we are going to do. So then the total, so it can integrate 30 plus different programming languages with it, and it can also works with CI pipelines and DevOps platform. That's the fantastic feature of Sonarqube. So because of that, most of the people are using Sonarqube. It doesn't mean they're not using other tools. They use other tool also based on the requirement. So now, writing a clean code. How to write a clean code? What's clean code? Writing clean code is essential to maintaining a healthy code base. What does healthy code base? Healthy code base, if you have a clean code, so you can have the proper healthy code base. So we define clean code as a code that meets a certain defined standard. That's code that is reliable. The first parameter under that is the code that is reliable, the code that is secure, the code that is maintainable, the code that is readable, and the code that is modular. So this is called as a clean code. In addition to having other key attributes, this applies to all code, source code or test code or infrastructure as a code or glue code or scripts, whatever it may be. As a DevOps guy and MLOps guy, you might have been writing plenty of scripts or plenty of codes. So it may be a source code, it may be a test code or test script. We have done it in Postman. Similarly, you can use some other tool to write a script, and you can write an infrastructure as a code. We have done it in Terraform, Packer, Ansible. You just go back and visit those videos. Nothing wrong. Just learning is nothing wrong. I keep on learning every day, every minute, every second I learn. What's wrong? Nothing wrong. Just go and watch and come back again. Nothing wrong. Learning is not at all a wrong thing. So, and similarly, we can have a glue code and scripts. It could be anything, but the code should be clean. Code should be modularized. Like if you have written the Python code, in spite of putting all thousand lines of pieces of codes into single file, a single .py extension file, you create a nice directory. Inside the directory, if you want to write a write different modules and put the directory name as a modules, and inside that you keep all this module files, module 1.py, module 2.py, module 3.py, and then you take only one main.py and connect all those modules with this main.py. See how nice it is, how beautiful it is. It looks more beautiful than your girlfriend if you write like that. Sometimes you may feel that coding is much, that whatever you have written, if you write like this, if you write a clean code, so clean code is beautiful than your girlfriend or your boyfriend, handsome than your boyfriend. Okay, that's fine. So that's what the clean code is. So now Sonar's a clean Sonar's clean as a code approach so eliminates many of the pitfalls that arise from reviewing code at a late stage in the development process. The clean as you code approach uses your quality gate. This is very important. We are going to do this. We are going to including this in a project to alert or inform you when there is something to fix or review in your new code or the code that has been added or changed. New code here means, or new code I mean the code that has been recently added or changed or pushed or committed. So allowing you to maintain high standards and focus on code quality. So here the concept of quality gate is nothing but, so you can set up, okay, if the new code that has been added, if it brings 5 bugs and 2 vulnerabilities, it has to alarm, it has to make an alarm that so it has crossed the threshold. Then immediately the quality gate says it's failed, the quality gate fails. So then the next step won't be executed. So in that way, this will be useful. This will be very much useful in our pipelines or MLOps pipelines or DevOps pipelines. Developing with Sonar. The Sonar solution performs checks at every stage of the development process. We have Sonar Lint. Sonar Lint provides immediate feedback in your IDE as you write a code, so you can find and fix issues before a commit. So here what we are discussing is the ecosystem of Sonar to save us from the bugs and vulnerabilities. In other way, the ecosystem of Sonar which can assist and support us to write a clean code. Clean, okay? Clean, a modular, a clean, a reliable, clean, a readable. Clean means a secure, clean means a maintainable. So a maintainable, a readable, reliable, secure, and modular. So this kind of code can be written to make that is possible. Sonar provides a complete ecosystem. So the first one in that ecosystem is Sonar Lint. So Sonar Lint provides immediate feedback in your IDE as you write code, so you can find and fix issues before a commit. So then we have Sonarqube's PR analysis that fits into your CI/CD workflows with Sonarqube's PR analysis and use of quality gates. So then we have quality gates concept. The quality gates keep code with issues from being released to production. That's the main thing. We use this quality gate concept in the pipelines, in the CI/CD pipelines of DevOps or MLOps. Okay, so this quality gates keep code with issues from being released to production. A key tool in helping you incorporate the clean as you code methodology. So then the clean as you code concept of Sonar approach helps you focus on submitting new clean code for production, knowing that your existing code will be improved over time. So organization starts off with a default set of rules and metrics called Sonarqube Quality Profile. This can be customized per project, and then This can be customized per project to satisfy different technical requirements. Issues arised in the analysis are compared against the conditions defined in the quality profile to establish your quality gate. Then a quality gate is an indicator of code quality that can be configured to give a go or a no-go signal on the current release worthiness of the code. It indicates whether your code is clean and can move forward, or so what's the representation of it, how it designates a passing green, you see that, a passing green here, a passing green quality gate means that code meets your standards and is ready to be merged, and a failing ready to be merged, do you see that? Okay, if it is a failed one, a failing red quality gate means that there are issues to address, then immediately it will get back to the initial IDE, it will go back to the IDE. So Sonarqube provides a feedback through its UI, email, and in decorations or on pull or merge requests to notify your team that there are issues to address. Feedback can also be obtained in SonarLint supported IDEs when running in connected mode. So Sonarqube also provides in-depth guidance on the issues, telling you why each issue is a problem and how to fix it, adding a valuable layer of education for developers of all experience levels. Developers can then address issues effectively. So code is only promoted when the code is clean and passes the quality gate. On the other side, if quality gate passes with a green light, so with a green symbolism, so it will go further, it will go for the merge and promote, and it will finally get into the production ready so that it can be exposed to the external world. So let me repeat it one more time quickly, a quick a cycle of Sonarqube ecosystem. So it begins with uh, it begins with the IDE. That's where the coders, the developers begin. So the code has been pushed, and after that, so it will be committed, and then after the commit been pushed, and once it's pushed, it's time to build and test it. We'll use different kind of tools, so all will be used and then built and tested. Once it is done, then it goes for the source code analysis. That's a source code analysis. So there we'll set up, okay, you check it. If it crosses this many bugs and this many vulnerabilities, you just raise a red flag. So initially it's a red flag. So as it is a red flag, now it will get back to the developers. So developers will look into that and see, okay, that's the issue. So now it's time to check it. But if you want to effectively and efficiently check that, you need the code should be clean. CLEAN, clean. Okay, what is clean? You should know by this time. Okay, so that's one case. And another case, if the gate was passed, if the gate is passed, the quality gate is passed, and the green, the symbolism will be in green, so then it will be merged and promoted to the higher stage. So where once it is ready, then it will be packaged and then it will be moved to the production, into the production server. Hence it is production ready. So now it will be accessed by the users. So installation is done. Now it's time to logging into the Sonarqube UI, and we will explore the user interface or Sonarqube user interface client. This is how it looks, but first let's get into that and we'll see. So here is that Sonarqube. So now log into the Sonarqube. As we have discussed, just use admin and admin. That's it. Username is admin and password is also admin. If you want to change the password, you can later change. But once you log into the system, then you can do the change. So I'm logging into the system. Yeah. So now you can give your password. So you see admin and yeah, and update the password. So the password got updated and here is your Sonarqube UI client. Okay. So just to get started, they're prompting how do you want to create your project. So they got all these facilities with them. So do you want to benefit from all of Sonarqube's features like repositories, import and pull request decoration? So create your project from your favorite DevOps platform. First, you need to set up a DevOps platform configuration for that. Okay, so you can use it from Azure DevOps, from Bitbucket Server, from Bitbucket Cloud, or from GitHub, or from GitLab. So GitHub, GitLab, whatever. So you have different tools you can attach in different pipelines which were built by which are made by different tools. So in anything you can attach your Sonarqube and you can make it as a part of the DevOps pipeline or DevOps platform. Or if you just want to, are you just testing or have an advanced use case, just create a project manually. So either you want to create your project using these DevOps Azure DevOps tools, or if you just want to explore it, if you just want to play in the playground of Sonarqube, just click on manual. So let me click on manual. Yes. So it's just asking the project name. For now, I'll give Sonar 1. So Sonar Code Analysis. So that's the project name and that's the project key. So the branch name is main. I'll give. So we're gonna use that. So branch name is main. So once you open your project, so the following information you're gonna get. So how do you want to analyze your repository? So do you want to integrate with your favorite CI, continuous integration pipeline? For that, to build a continuous integration pipeline, you can use any of these tools. With Jenkins, you can build a continuous integration pipeline. With GitHub Actions, with Bitbucket pipeline, GitLab CI, with Azure pipelines, or any other CI tool that you have that you can mention here. Okay, let me go back a bit. Yep. Or you just testing or have an advanced use case, so you can just go with this. So I will analyze our project locally. So let me click on locally. I'm not making this a part of any continuous integration because we just want to explore this first. Yeah. So it's saying analyze your project. So we initialize your project on Sonarqube. Now it's up to you to launch analysis. Okay, so we're gonna do that, but before that we have to generate a token so that the token can be used in in the token can be used to incorporate or integrate the Sonarqube with the pipelines. Okay, so let me make it either 90 days or 1 year, no expiration. Even you can put the no expiration, but I'm gonna go with 30 days. So the token name, analyze Sonar code analysis. Let me keep it same, or sonar token, sonar token. And let me generate the token here. So let me click on. So here is the Sonar token, and you can just copy this, yeah, and use it for later uses. I'll take the sticky note and I'll paste it here. Yeah. So our token is ready. The token is used to identify you when an analysis is performed. If it has been compromised, you can revoke it at any point in time in your user account. So let me click on continue here. So now this is a Sonar token, and before that, so run analysis on your project. So what option best describes your build? So which tool you're gonna use to build your project? So if you remember, we have used the Maven tool to build a Java package. So that's why I'm going to go with the Maven again. So to execute the scanner for Maven, so this is what we have to use: Maven clean verify Sonar, and inside that these are the codes, or these are the instructions that should be entered. So running a Sonarqube analysis with Maven is straightforward. You just need to run the following command in your project folders. Absolutely correct. That's what we are gonna do. So let me copy this also and paste it here. Yeah. So let's click on dismiss and let's move ahead. So that's the overview. So here you can get the more information. If you want to put it to embedded database, that also you can work on that, but that's enough. So provide a token and the run analysis on your project, and once analysis is done, you can get back to this place. Okay, that's how you initiate a project inside a Sonarqube. But before that, we will see the UI of this user interface of Sonarqube UI-client. So let's see the first, the top header. So this is the main menu. So this consists of a Sonarqube logo. So logo, this link to home page. Let me click on this. Yes, this is the home page. So whatever so far we are seeing is the project phase. There's a project page. So now we have reached the we have got into the home page. So in this home page we will have informations about all the projects. So we have created a project called Sonar Code Analysis, and you can see that on the screen here, exactly in front of your screen. Okay, so that's what the project. And here in the project tab inside on your main menu, you should see all the projects that are part of this Sonarqube server. So if you want to create a new project, you can just click on the create new project, and here you have two options. One is manually, so you have to do it manually, or you want to integrate it the DevOps pipeline again. So if you want to get back to the home page, click on Sonarqube. So that's all about the projects here, the projects tab of main menu. So then we have issues. This is the issues page, and one more thing about projects page is so here you'll have all the information, or the testing or code analysis information. You see that on the left vertical bar, on the left bar. So you have the quality gate. If you have given a quality gate, it will tell you whether it is passed or failed. It's green and red, and it talks about the reliability. That's about the bugs. So ratings: A rating, B rating, C rating, and D rating, and E rating. So that's what. And the next parameter is security. That's how we confirm whether that code, that source code that you have written, is a clean code or not. using these parameters. Security review. You see that security review. Basically, security review depends upon the security hotspots. Then we have maintainability. That's a code smells. We call it as a code smells. And again, they were segregated as A rating, B rating, C rating, D rating, U rating. So then we have coverage. In coverage again, we have different sublists, and we have duplications and sizes and size, and finally the language and then tags. Okay, this is the complete analysis of the this project. Here you will get the complete analysis of the project with various parameters. So now let's get into the issues tab on the vertical menu, or sorry, on the main menu. So in these issues, at this moment, no issues. That's okay. We haven't done anything to get issue. Okay, so what are the types of issues? If I click on this bug, so all the bug will be filtered. Now let me clear the bug. If I click on vulnerability, so the vulnerabilities related information will be filtered. I'll click on this, and then code smell related to the maintainability. Okay, so if you click on code smell, so all the things that are related to the code smell will be filtered. So let me clear this. Let me clear all filters. So that's the type using filters. And then after the severity, how severe they are. So blocker, will it a block, or it's a minor, or it's an information just, or it's a major, or it's a critical. So these are the severity. Based on these icons, you should be able to see that the severity of that issue. The issue could be a bug, or the issue could be a vulnerability, the issue could be a code smell. Okay, so then we have scope. Here scope again, is this the main code or the test code? So that information will get it. And the resolution, is it how many are resolved, how many removed, how many fixed? That's a result. How many fixed, how many false positive, how many won't fix, how many can't fix, and how many are unresolved. So that's the information you get there. And then you have the status. So in status again, with each issue we can see whether the status is open, or is it confirmed, is it resolved, or is it closed, or it was closed and then reopened. So then we have security category, sonar source, WASP, top 10, and WASP top 10, 10 SANS, CW. So these are the security categories, and it will categorize your issues into different security category based on their intensity. Then we'll get the more information about the creation date and language, then rule and the tags that are attached to that, and we have the project related information, or we can just search the projects here, and then assignee to whom that was assigned, and then author. So that's all about the issues. And here you can see that how many issues are there. At this moment there are no issues, but if you see that issues here, you should be able to Sonarqube will categorize that issues, and then it will highlight all the informations on this. And then you have effort issues and all that. So now let's get into the rules item in the menu. So search for the rules. If you want to give a specific rule, you can search for the rule, or if you want to use it for a language, Java, C, JavaScript, TypeScript, PHP, Python. So I want to give it for the Python. Just let me click on Python. So these are the rules we can attach for the Python. Okay, you see that the different rules we have. The first rule is less than, greater than should not be used to test inequality. Okay, but some people might use it as an inequality, but that should not be done. So that's one rule. And we have underscore init, and then underscore should not return a value. Of course, if it returns a value, then one more bug. So it's a Python bug. You see that? It's a Python bug. So that's how we the Sonarqube consists of a certain rules, and these rules can be used to find out the issues. And you have a HTML rules also. You see that doc type declaration should appear before HTML text. Fantastic. It should not appear after that. So, and then Terraform, you see the Terraform rules, Ruby, Scala, Go, even XML rules. You can see that each language has a rules. And then I'll scroll up, and if you want those rules specific to the type, so let me click on Python again, and then scroll down a bit. And if you come here, so total Python has 60 bug type rules, 16 vulnerability rules, 111 code smells, that's a maintainability rule, and 43 is security related rule. So let me click on bug type. So now these are all bug type rules. You can see that the Python bug, Python bug, Python bug. Inside the one of the bug that you're gonna get is equal plus should not be used instead of a plus equal. Yes, that's absolutely right. Some people use that. Okay, that should not be done at all. So equal plus is the right way of doing that. X is equals to x plus 1. That means x is equals to x plus 1. X is equals to plus 1. X equal to plus 1 means x is equals to x plus 1. So for that, you should use equal to plus only, not plus equal. So these are called bugs. So now let me click on vulnerability, and these are called vulnerability rules. So one of the vulnerabilities, so how can vulnerabilities comes? A secure password should be used when connecting to a database. Yes, that's the one. If you don't use a secure one, so that comes under a vulnerability. So basically it cross checks the source code, and it protects from every front, so that your application is not attacked by anybody, so not hacked by any hacker. And one more, if it is AWS IAM policies should not allow privilege escalation, and a few more. So now let's look into the maintainability related rules. That's a code smell. So code smell, again, we have seen that the code smell. Okay, and exception and base exception should not be raised, and pass should not be used needlessly. So the more you can just go through it one by one. So if you want it for the Python, you can use it, as we are ML engineers, we are data scientists, we do ML ops. So that's why I'm specifically talking about the Python, because that's where we have to work on. Of course, for us, other tools such as HTML also comes into the picture, and then JavaScript a bit, Java, and sometimes there's PHP, sometimes they get into the Scala, but that's okay. And CSS is the one more thing that we use widely. So let me click on to the CSS, and now let's cross check. So CSS has two tabs only because it can have vulnerability. So it has a bug, and so 16 bugs, and the 9 code smell. So what are the bugs in CSS? For CSS, the bug is important should not be used on keyframes. Yes, perfect. And at hyphen rules should be valid. Okay. Calc operations should be correctly spaced. Yes, brilliant. So color definition should be valid. Okay, these are proper. So these are proper bugs. Yeah. So code smell, if you want to see, so code smell CSS files should not be empty at all. So because if a CSS file is empty, so it will cause a maintainability problem. So that's the reason empty block should be removed. That's what this is called, a maintainability. So uneven, like unnecessary spaces, unnecessary empty blocks, unnecessary rules, this should not be kept. So these are all called code smell. So extra semicolons should be removed. Absolutely correct. Multi-line comments should not be empty. Brilliant. Selectors should not be duplicated. Absolutely right. Okay. So that's a lot. That's a lot about rules based on the type. And if you want to look into the rule, it's a few more things. Here you will get the tags. You can, and then repositories and default status and other information. But the most important thing is language type, and then specific and their rules specific to their rules. So then we have quality profiles. So in quality profiles, you can see that quality profiles are collections of rules. That's it. We have seen the rules before here. So now let them collect it, let them group it, and then we call it as a quality profile. So let me click on quality profile. So quality profiles are collections of rules to apply during an analysis. For each language there is a default profile. So all projects not explicitly assigned to some other profile will be analyzed with the default. Ideally all projects will use the same profile for a same language. And here you can see some of the profiles. And let's take a C. Let me filter it using cloud formation, no docker, HTML. Let's get into the HTML and see the one profile we have. For HTML we have only one profile, that's a Sonar Web built-in. So if you total, it consists of 28 rules. Now let me click on. So all this one, if you use this profile directly, so all these rules will be applied and it's gonna cross check across your source code, and it will try to find out these 16 types of bugs and 0 vulnerabilities and this 10 types of active. These are the active 28 plus total 16 plus 10 and plus 2. So total and these kind of code smells and these kind of security hotspots, it will try to find out these issues inside your source code. If it finds, and it's gonna throw you, okay, these are the problems, these are the issues in your system, so it's better you solve it before you put this into the production. That's what it's gonna tell you. Okay, so that's what the profile is. If you want to see more, if you want to see one more, so let me scroll down a bit, down, and here is the Python. So Python has one profile, and this profile consists of 183. That's 183 rules. Absolutely fantastic. So then when you use this profile directly, so it's gonna look for 53 bugs and 53 types of bugs, because these are 53 rules of bugs it consists of, and 15 types of vulnerabilities, and 79 types of code smells, and 36 types of security hotspots. So how much ever it finds, it will throw you everything in front of your screen, and you have to decide if it is a manual way. If you put everything is in pipeline, then you'll get it as a feedback to the developer. The developer has gonna solve that issues one by one. How nice it is. Brilliant. Yes, it is. That's what we call as automation. Okay, that's what about the quality profiles. So then we have a quality gates. So quality gate, as we have discussed earlier, the quality gate compiles with the clean as you code methodology, so that you can benefit from the most efficient approach to deliver a clean code. So what is the benefit of that? So what's the benefit of delivering a clean code? So delivering clean code brings up a new brings up a source code with no new bugs. So it brings up a source code with no new vulnerabilities, and it brings up a source code, or it pushes a source, it brings up a source code with no new security hotspots. No new code has limited technical depth, and no code has limited duplication, and new code is properly covered by tests. So these are the benefits it's gonna bring it to us when you go with the clean as you code. But for that, what you require, you need to put a quality gate. So what's the quality gate? So for example, some of the conditions are put here. Either the conditions on new code, you can put the quality gate only for the new code that's been committed and pushed to your repository, or you can just put the quality gate for the entire code. It's not a big deal. You can do it either way. However, so some of the examples here, you can see some of the conditions to write a quality gate is: first, the coverage metric; coverage metric should be less than 80%, and duplicate lines. This is very important. The source code should not consist of a number, like hell number of duplicated lines. So that's the reason. So duplicated lines should not be. It should be greater than. It should be greater than 3.4%. It should. It duplicated lines is greater than 3%. So if it is greater than 3%, that's it. Just block the movement, just block the, because just block the flow of this source code into the next stage in your DevOps pipeline, because this is not clean. Will you drink unclean, unhygienic and chemical water? You don't know. Then why do you want your system to fill up unhygienic and unclean and infected water? Why do you want to do that? Don't do it. So duplicated lines, again, if it is more than 3%, just stop it. That's it. So then maintainability rating, if it is worse than 5%, they're gonna do that. They're gonna do enough calculation. If it's less than 5%, just break the flow. Just break it. So then we have reliability rating. If it is worse than, yeah, so it has a coding there. If it is worse than, it's bugs. If there are no bugs, it's fine. If it's worse than, yeah, then issue. So then security hotspot reviewed. It should be less than 100%, and security rating is worse than, yeah, so no vulnerability. So that's how. So some of the conditions you can give, all conditions, a few conditions. It's all up to you to go for a default gate, quality gate, or you can make your own gateway, where one quality gate. So this is Sonar way. It's a default built-in gateway. So if you want to make it a new gate, so you're gonna write your gate name. So I'll say Maven or a CI gate. Okay, and let me click on save, and here is that. So now this is your CI gate. So you want to set as a default, so like whenever you server comes into the action, you want to run it the CI gate, so then you have to click on CI default. So now this is no more a SonarWay as a default gateway. This is just a SonarWay as a built-in, that's it. Now CI gate is the default one. So now these are the existing some of the conditions. If you want to change the condition, you just come here. So I'll make this as 90%. 80 is not enough for me, so I'll update this condition. So then I have duplicated lines. I don't want it. I don't want even 3%. I'm going to bring it to the 1%. So I want as clean as I want a code which is as clean as pure Himalayan water. And so maintainability rating, that's fine. Rest all will keep it same. We don't touch it. So just unlock the editing if you want everything, like even other parameters also, other issues also, but I'm not much worried about these things for now, so I'll keep it same. So that's it. And if you want to grant permissions to a user which are part of your group, you can do it from here, but I'm not going into that now. That's how we create your, if you want to add new conditions, you can add that. Let me show you. So these are the default conditions. If you want to add your new condition, so now it's asking whether you want to apply this condition on only new code which has been now or which has been recently pushed, or you just want to add, you just want to apply this condition across the code or overall code. So I'll go with the new code only. So I don't want to do it, I don't want to repeat the same thing again and again. So that's why I'm going to do on new code. So now it's asking what type of rule you're going to with, what type of condition you want to set. A condition coverage, conditions to cover, line coverage, lines to cover, uncovered conditions, uncovered lines, and more. A lot of information is here. So blocker issues, critical issues, so major, minor, code smells. You see that code smells, bugs. So I'm gonna take the simple one. I'll click on bugs. So if bugs are more than 60, just break it. Just break the flow of the pipeline. That's it. Yep. So it's taking time, let it take time. Okay, it got updated. So now let me um, so it got updated. Now it's time to add a condition. So let me click on condition. Yes. So it should be added to that, and here is that the bugs condition that we have recently added. It's greater than 60, then that's enough. So, and if you want to look the information here, so let me click scroll over this. You added an extra conditions to the clean as you code quality gate, which is something we do not recommend, but we don't care. We want to customize our conditions. Okay, so then I'll click on one more add condition. So this time I'm gonna click on overall code. So I'll scroll down more and I'll completely come down, and then I'll go to that what is that? I forgot that. Comment lines is fine. Yeah, comment lines. Yeah. So comment lines, I'm gonna put so I don't wanna more than 60. That's it. 60 is fine. If you put it more than that, that's enough. I don't want more than that. So the this one is also successfully added. You can see that bugs, and let me scroll down and show you conditions on overall code. So here on top you can see the conditions on new code. That's it. But here only one condition that we put on overall code, that's comment lines. Okay. Yeah. So that's all about the quality gates, and then now we can come to the administration. So here, this is where we can do all the administration. So a configuration, encryption, webhooks. This is where you'll get the webhooks. Let me click on webhooks, and then webhooks are used to notify external services when a project analysis is done. And HTTP post require a request including JSON payload is sent to each of the provided URLs. So that's what the webhooks. And if you wanna see and explore more about the webhooks, get into this webhook documentation. So then we have security. This is where you can create a group. At this moment, administrator, admin is the one guy. So but if you wanna make a group, you can just click on groups, and here is that. And global permissions and permission templates you can have here. And this is the projects, how for the project management. And you have the systems, and finally you have marketplace. This is anyway not important for us at this moment. Okay, this is all about the administration. In addition to this, this UI consists of a search bar. Here you can search it, and here you will get into the documentation with the question mark icon, and then here this is the user profile. Okay, so administrator, so my account, and then logout option. And as usual, you'll have a footer, and it's all about the Sonarqube and Sonarqube information and various other external links to for your learning. So we have seen enough. So now let's look into some of the concepts, theoretical concepts, and then we'll get back to the project again. So we get back to our slide. So we have seen the Sonarqube user interface in detail. So now let's move on to what is analyzing source code. So once the Sonarqube platform has been installed, you're ready to install a scanner and begin creating projects. To do that, you must install and configure the scanner that's most appropriate for your needs. Uh, so which tool we're going to use it? Of course, we have gone through this phase in our, let me show that again. It's not a big deal. So let me come to the projects. So this is the, so configure analysis. Yeah. So we have to decide which tool is best fit for that. Let me create a new project. So create a new project. So this time I'm gonna say uh, solar code analysis, sonar code scanner. I'll keep it main, and I'll go with the local at this moment. And exist token is we'll use existing token. It's not a big deal. So the token sonar token. I gave the sonar token. Yeah, token you have entered as invalid format. Okay, sonar token, and click on continue. So now it's asking run analysis on your project. So for that, which tool you require? So Maven, Gradle, or .NET, or other one. So let's go with Gradle. So this is what the scanner I'm talking about. Execute the scanner for Gradle. So for that, what we have to do to execute the scanner for Gradle, we need to you have to running an analysis with Gradle is straightforward. You just need to declare that org.sonarqube plugin in your build.gradle. So if you know the build.gradle, so if you know the file Gradle, the building with Gradle, you will have a build.gradle file. In that file, you have to declare that this as org.sonarqube, and that's it. So you see that this is one example. Copy this and put it there directly. That's it. This is the one of the plugin. So you have to attach this plugin to that so that the scanner, the Sonar scanner can be connected with the Gradle. So when you build a project, when you build a package, when you build when you build an application with the, we have seen in Maven, right? You should get what, when I say build, you should get what I'm speaking about. So the Sonarqube, so the Sonar will work with a build tool Gradle in this case to scan the lines of each source code, each and every line of the source code. That's what is going to happen. In addition to that, we have to run the following command. Yeah. So what is this? This is the information about the project. So project key Sonar code scanner, and then the Sonar host URL. You see that this is the host URL, and you can see that here 3108555214, and then login Sonar token. So that's what we have given, the token Sonar token. So that's it. So in this way, we can just copy this here and then place it in the build.gradle file, and you should able to install the scanner with your build tool. So now let me click on .NET, and you will find a difference. In .NET you have two types, .NET framework or .NET core. So let me click on .NET, and this is the first command, .NET tool install global .NET Sonar scanner. That's it. You copy it and you paste it and you execute it, and that will be installed. And after that, you have to execute the few more commands. That's the remaining commands. The first command basically makes the connection between the project, host, and then login with the build server. And then you say .NET build, and that's it. Your project will be built. It's pretty simple. And other, here is that. If you have any JavaScript, TS, Go, Python, PHP, so you can follow this. Let me click on Linux. And here is the way for Python. If you want to do it for Python, as we are the ML engineers, so if you want to do it for the Python, and this is the way, execute the scanner. So to execute the scanner, so running a Sonarqube analysis is straightforward. You just need to execute the following commands in your project folder. So these are the commands you should be put into your project folder. So I will show you with one example, one project, but for now you just understand this, what I'm talking about. Okay, so let me get into that. So these are some of the tools. Anyway, you can use this in collaboration with other tools. So a project is created in Sonarqube automatically on its first analysis. However, if you need to set some configuration on your project before its first analysis, you have the option. I'll show you that. So let me click on Sonar. Okay, let me come to the projects directly. So let me close that. Yeah. So you have two projects now. If you want if you need to set some configuration on your project before its first analysis, you have the option of provisioning it via administration options or the plus menu item, so which is visible to the users for the project creation rights. Okay, so using that you can do the changes. You can click on the administration, and here you have that analysis, scope, authentication, externalize, and a lot of other options. Let me click on SCM and technical data. Okay, so projects, so project management, and here is that you can do that last analysis. And if you want to edit the permissions, apply the permission templates, or if you want to do the any configuration of this existing projects, you can just click on that project and again you can redo that. How do you want to analyze your project? You can redo that. For that you have to get into the administration, nothing much, or you click on the project settings, you will get all the information here. Quality, get quality profiles. Anyway, we are going to do this, we are going to do that, do this. Okay, so let me get back to the slide. So then, but after all this, what does analysis produce? That's the question. That question comes, obviously. So Sonarqube can analyze up to 29 different languages depending on your edition. The outcome of this analysis will be quality measures and issues. However, what gets analyzed will vary depending on the language. On all languages, blame data will automatically be imported from supported SCM providers. Git and SVN are supported automatically. Other providers require additional plugins. On all languages, a static analysis of source code is performed. Example, performed on Java, files, COBOL programs, etc. For certain languages, the static analysis should be done on compiled codes. So that's the difference. It varies with the type of language that we are using. So if it is Java or COBOL kind of program, so the static analysis of source code itself is performed. The source code on the source code. Or if it is dot class files in Java or dot DLL files or in C language, then a static analysis will be done on compiled code. Like for the Python, you'll do it on the source code as well as the compiled code, that's .pyc extension. So the next question that arises is, will all files be analyzed? By default, only files that are recognized by your edition of Sonarqube are loaded into the project during analysis. For example, if you are using Sonarqube Community Edition, which includes an analysis of Java and JavaScript but not C++. So all .java and .js files, these are extensions, .java and .js extension files would be loaded, but .cpp, that's the extension for C++, .cpp files would be ignored because that edition does not have that capability. Now they are rebuilding it. Okay, so then the next question that pops up to your mind is, what about the branches and pull requests? So developer edition adds the ability to analyze your project branches and pull requests, as well as the ability to automatically report your pull requests analysis to your DevOps platform interface. Absolutely brilliantly works. That's how we build a MLOps pipelines, a continuous integrated and continuously delivered pipeline, MLOps pipeline. Okay, the next question is, what happens during analysis? So during analysis, data is requested from the server, the files provided to the analysis are analyzed, and the resulting data is sent back to the server at the end in the form of a report, which is then analyzed asynchronously server side. And what happens during analysis? So during analysis, data is requested from the server. The files provided to the analysis are analyzed, and the resulting data is sent back to the server at the end in the form of a report, which is then analyzed asynchronously server side. So that's all about Sonarqube analyzing a source code. Now let's see how to integrate a GitHub with our Sonarqube. So Sonarqube's integration with GitHub Enterprise and github.com allows you to maintain code quality and security in our GitHub repositories. So with this integration, we'll be able to import your GitHub repositories. So import your GitHub repositories into Sonarqube to easily set up Sonarqube projects. And you can analyze projects with GitHub Actions. So integrate analysis into your build pipelines, starting in Sonar scanners, running in GitHub Actions. Jobs can automatically detect branches or pull requests being built, so you don't need to specifically pass them as parameters to the scanners. And we can report your quality gate status to your branches and pull request also to see your quality gate and code metric results right in GitHub, so you know if it's safe to merge the branch, uh, to merge the changes or not, the changes or the branch to the main. And authenticate with GitHub. So you can sign into Sonarqube with your GitHub credentials. And finally, you display code scanning alerts for vulnerabilities issues in GitHub. But how do you do that? Let me show you. So again, you have to create a project. Let me click on main. So get the most out of the Sonarqube with the branch analysis. Okay. So now what you have to do is, this is using GitHub Actions, GitLab CLI, and projects. So create a project. Proj1. So setup. So with Jenkins or with GitHub Actions, GitLab, and other CI tool. So for now, so instead of going for the local, you have to go for the Jenkins or GitHub Actions, whatever you want. So I just clicked on GitHub Secrets. So now in your GitHub repository, in this settings, you have to change the secrets and create the two new secrets. So this is the procedure you have to follow to make that connection possible. You just go through it and you can do it. So that's the first step. And after that, once it is done, you have to create a workflow YAML file. Then you are all set to done, and whatever you want, you can do it. For each and every issue, for a quality gate fail and pass, you're gonna get the information. So that's what. So you can do that. It's a pretty simple. Yeah, here it is. Now let's get into some of the core concepts of Sonarqube, such as architecture and the fundamentals. Basically, we'll look into the fundamentals before we jump into the project. So, what's the architecture of Sonarqube? So, Sonarqube consists of, it depends upon three concepts. One is analyzer, second one is database, and third one is server. So what's analyzer? Analyzer, a client application that analyzes the source code to compute the snapshots. That's it. That's the main one. And database. What does a database do? Database stores configurations and the snapshots that was created by the analyzer. So it's like a report. The report is created by the analyzer. And what does server do? Server, a web interface that is used to browse a snapshot and make configuration changes. It's pretty simple. You will have a front end, you will have a back end, you will have an engine. That's it. The front end is the main thing. So that's where everything happens. This server will have a web interface, and through that web interface we're going to do some actions. Or you can do the actions without using the web interface through pipeline or through GitHub, through some other way. So that's the server. And instructions will go through the web interface to the analyzer. What is analyzer? Analyzer is the engine. It's the powerhouse. That's where the action takes place. It's like it's a client application that analyzes. It analyzes the source code. That's what does the action. So it will do that action, and the source code, it will do the analysis of the source code, and then it will convert that analysis so of the each source code into the a report, or we call it as a snapshot. Now where will the snapshots will be stored? Obviously database. So we'll have a database, and inside the database we're going to store the configurations and snapshots. So that's what the SonarQube architecture is. Pretty simple. It's like normal a web application, normal a dynamic web application. So a database, a server, and analyzer. Now let's dig deep into the some of the SonarQube concepts. So we'll begin with quality. So what all stuff that a quality consists of, such as bug, code smell, cost, depth, issue, measure, metric, new code definition, quality profile, rule, remediation, cost snapshot. Everything we're going to understand using this. So let me get it here. Yeah. So come to the projects. And here you should see. So let me come to the issues, and so here you should find out all some of the examples. Let me click on, let me zoom in. Yeah, so I'll scroll down one by one. Yes. So first one, it begins with three types mainly. After that, it's severity. The first one is bug. You see that? You can see that on the screen. Bug. What does a bug mean? So it's widely used by software guy. A bug, a bug, a bug, a bugger. So bug is an issue. It's an issue. You see that? We are in issues tab. Represents that issue, that represents something wrong in the code. If this has not broken it will, and probably at the worst possible moment, this needs to be fixed. This needs to be fixed. And I'll show you one example of the bug rule. So I'll go to the Java, and this is the bug, the first one. So what's the bug? So equals and open and close parentheses should not be used to test the values of atomic classes. If you use this, that's called as a bug. And equal plus should not be used. Instead of, you have to use plus equal here. Okay, plus equal, not other way. So, and one more bug, let me scroll down, let me click on bugs only here. So let me scroll down. Yeah, Java, and let me filter this using bugs. Yeah, so one more bug for Java. Bug is filtered. So one more bug, at the rate of non-null value should not be set to null. That's correct. If you set it, you're going against the rules of Java itself. Then obviously it's a bug. But what will happen if you do that bug? If you keep that bug, so if this has not broken if it will, and probably at the worst possible moment, this is gonna create an issue. So that's why it needs to be fixed. It needs to be fixed at any cost. So that's what the bug is. And the second one we have is code smell. You see that, the code smell here? So I'll come to the issues, and here is the code smell. So what's code smell? Code smell, a maintainability related issue in the code. Leaving it as is means that at best maintainers will have a harder time than they should making changes to the code. At worst, they will be so confused by the state of the code that they will introduce additional errors as they make changes. That's the biggest and the worst aspect of Postman. So I'll show you. I will select the simplest one for so that it will be easy for. I think most of you guys know because you are data scientists. Most of you guys working on Python. So I'll show you the code smells of this. Okay. So some of the code smells. Pass example pass. Pass should not be used needlessly. Okay. What happens if you use continuously? That you have to answer. Okay. And total 111 we have, and one more. So I'll just scroll through it. So double prefix operators, not and these two things, not and tilde. Not and tilde should not be used. If you use it, what will happen? And functions and methods should not be empty. You just simply randomly you write a function and keep it empty. No, those are very worst things. And even functions and lambda should not reference variables defined in enclosing loop. Functions returns should not be invariant. Even that also. You write a function and you give some arguments, or we call it as a parameter because we are defining the function. But inside the function, in the second line, you write a return statement. Inside that return statement, you should not leave it. You should not leave it empty. And there are more. So what happens is if you have this uh, code smells, if you have this code smells inside your source code, so after that, this may lead to some errors or some bugs. So when it leads to some errors, so the maintainer has to come and check, and he has to find out, and he has to solve that. So for them it will be a nightmare. In addition to that, this code smell is going to create new kind of errors. It's going to impact the other functions, other functionalities of the your application. So it's going to lead to new types of errors. So that's the reason you have to be very damn careful about this code smells. Okay, let me get into the issues. So in addition to that, we have a lot of other information. So scope, resolution, and status, security category, creation date, and language, and rule, tags, a project, other. Okay, let me scroll down. I'll give it here. So a few more things here. So these are different tags that were given. So few more things to be discussed in the quality. The next thing is cost. So cost and debt, these are all. So few more tools, those are widely, few more issues they are used. And in addition to that, the most important thing that I just want you to understand is issue. What does an issue mean? Okay, here is that you can see that issues, and these are all the issues. There are mainly three types of issues, and after that, that's a severity of each issue. So what does an issue mean? So when a piece of code does not comply with a rule, an issue is logged on the snapshot. An issue can be logged on a source file or a unit test file. So there are three types of issues mainly. One is bug, code smell, and vulnerability. So we have discussed a bug, a code smell, but we haven't discussed about the vulnerability. But these are all called as issues. So here you can see that main three types of issues. That's a bug and vulnerability and code smell. Okay. So then we have a few more concepts to understand. We measure. How do you measure that? So the value of a metric for a given file or project at a given time, for example 125 lines of code on class, my class, or density of duplicated lines of 30.5% on project of my project is called the measure. How do you measure that? So let's get into the rules. and quality profiles and quality gates. Now you can see that this is the value. This is called the measurement. This is what we call as a metric. You see that? The metrics. These are all called the metrics. So how many metrics we are used? These are conditions, but the values are called because we are using the measurement. So that's what we call it as a metric. So or a measure. So this metric, a type of measurement, metrics can have varying values or measures over time. Examples, some of the examples that you can see on your screen, but I'll tell you a few more. So number of lines of code, complexity. A metric may be either qualitative, means gives a quality indication on the component. Example, density of duplicated lines, line coverage by tests, etc. Or quantitative, it does not give a quality indication on the component. Example, number of lines of code or complexity, etc. So that's what the metric. Here you can see both. One is qualitative, a technical debt ratio is less than 5.4 debt, and others are quantitative, example bugs which are greater than 60. Okay, so that's a different metric. So either you can go for the qualitative metric or quantitative metric, but this is one type of measurement. Okay, and a few more concepts. That's a new code definition. What is the new code definition? And a change set or periods that you're keeping a close watch on for the introduction of new problems in the code. Ideally, this is since the previous version, but if you don't use a Maven-like versioning scheme, you may need to set a time period such as 21 days. So after that, whatever the code that enters, the code that you pushes is can be called as a new code. So then we will see quality profile. A set of rules. Each snapshot is based on a single quality profile. So a set of rules is known as a quality profile that we have discussed. Here you can see that a quality profile. And then a coding standard, a rule is nothing but a coding standard or a practice which should be followed at any cost so that you can have clean as you go code, a clean code. So not complying with coding rules leads to bugs, vulnerabilities, as security hotspots and code smells. So rules can check quality on code files or unit tests. It can be the rules, the whatever rules that we have in this quality profiles. Let me click on this rules. This set of rules is nothing but a quality profile. So in this rules, whatever rules that you mentioned that can be used to check for the source code and as well as the unit tests that you write to test your source code, test your application. So for both, it can be used. I think you're getting my point. I'll elaborate it. See, for example, you have built an application. So it's obviously source code. So now, so this source code can also be tested. This source code can also be analyzed, okay, using these roles. In addition to that, you write a test cases as we have written for the API in our previous part of this 7th module. You write the test case script. Now you can check that test case, you can check that, you can and do analysis for the test case script also. That's what I'm saying. Okay, I hope you got it. So then we have remediation cost. The estimated remediation cost is nothing but remediation. The estimated time required to fix vulnerabilities and reliability issues. That's what the cost is that. So a snapshot, a set of measures or issues on a given project at a given time. A snapshot is generated for each analysis. It's nothing but a report in a simple words. And what else we have here is a security hotspot, a technical debt and vulnerability. So that's what we're going to see. So a security hotspot, I'll show you. Come to the quality gates, sorry, issues, rules. Let me scroll down. Yeah. So we have seen the bug And now we're going to see into the security hotspot. Here is that. So security sensitive pieces of code that need to be manually reviewed upon a review. So you will either find that there is no threat or that there is vulnerable code that needs to be fixed. And let me click on security hotspot, and so that you can see some of the example of rules. So accessing Android external storage is security sensitive. Fantastic. And allowing both safe and unsafe HTTP methods is security sensitive. So that should not be done. And allowing browsers to perform DNS prefetching is security sensitive. So these are the rules related to the security hotspot. So you have to be very careful in dealing these things, or else you will be vulnerable for the attacks. So then what is vulnerability? I'm saying vulnerable for the attack. Then what does it mean? So vulnerability is nothing but a security related issue which represents a backdoor for attackers. Who is that attacker? A hacker. So that's what a vulnerability. Vulnerability is nothing but a security related issue. It is also an issue. Okay, but it's a security related issue. You can see that there are three types of issues: bug, vulnerability, and code smell. Okay, so a vulnerability is a security related issue. So what will happen because of this? Because of this, it creates or it represents a backdoor for attackers. So they'll enter into your premises, they will enter into your application premises, and they'll do whatever they want. It's like intrusion, intrusion into your application, invasion. They'll invade your app like Mughals did, Britishers did. So, and the one more thing that we have is technical debt. So the estimated time required to fix all these maintainability issues or code smells is called technical debt. That's it. So, and remediation cost, and then technical debt. So the estimated time required to fix all these issues are called as a technical debt, whereas the remediation cost is the estimated time to the estimated time to required to fix vulnerabilities and reliabilities issues are called remediation cost. So that's the difference between the remediation cost and technical debt. Okay, technical debt is only to fix all the maintainability issues such as code smells, whereas the measurement of estimating time to fix all the bugs and other vulnerability or security issues, we call it as a cost, a remediation cost, whereas if it is related to only maintainability, we call it as a technical debt. Let's look into the one more concept as a clean as you code. We have looked into before, but now we're going to dig deep into that. So what is a clean as you code? So clean as you code is an approach to code quality that eliminates a lot of challenges that come with traditional approaches. As a developer, you focus on maintaining high standards and taking responsibility specifically the new code you are working on. Sonarqube gives you the tools that let you set high standards and take pride in knowing that your code meets those standards. So let's focus on new code. So when with clean as you code, your focus is always on new code. So code that has been added or changed according to your new code. So definition, and making sure that the code you write today is clean and safe. And the personal responsibility, one more thing that's very part of clean as you code. So with clean as you code, you aren't responsible for anyone else's code. You own the quality and security of the new code you are working on today at this moment. If you add new issues, Sonarqube automatically assigns them to you so you can maintain quality in your code. and quality gate, which is also part of the clean as you code. These are the fundamental components of clean as you code, like what a personal responsibility and quality gate. So your quality gate is like a set of conditions that tells you whether you need whether or not your project is ready for release. So with the clean as you code approach, your quality gate should focus on either new code metrics. That's what when your quality gate is set to focus on new code metrics, like the built-in Sonarqube quality gate, new features will be delivered cleanly as long as your quality gate is green. So let me show that the quality gates. Let me get into the quality gates. So at this moment we have two quality gates: a Sonarqube that's a built-in, and then CA gate. So that's the one. And second one, set and enforce the high standards. When standards are set and enforced on a new code, you aren't worried about having to meet those standards in old code and having to clean up someone else's code. So the one more component of clean as you code is pull request analysis. So you can use pull request analysis and decoration to make sure your code is meeting your standards before you merge. So now let's see the project page. So the project homepage is the entry point of any project. So what it shows, let me get into the project page and I'll show you. So this is the project page. At this moment we have three projects in it. Proj 1, Sonar Code Analysis, Sonar Code Scanner. So, but what's that? Project home page is the entry point of any project showing. So what does it show? The releasability status of the project. The first one, the releasability of the project, because it will show you the overall status. You see that perspective, overall status of the project, and then a few more information. You have to sort by name, last analysis date, reliability, security review, maintainability, coverage, duplication size, everything. So you'll get the complete information. So by looking at this projects page, we'll get to know the releasability status of the project and the current status of its quality. You can see the current status of its quality and the quality of what has been produced since the start of the new code. And the project page specifically answers the main important two questions it answers is one, can I release my project today? So we vitally dependent on these projects. Why? So based on this project page only, we take the decision that can I release my project today based on the condition of the project, based on the bugs, based on the vulnerabilities, based on the security threats. So how well it's performing based on the code smells. So the first question, that the main question that's answered by the projects page is, can I release my project today? And if not, what should I improve to make the project pass the quality gate? That is the main purpose of this project page. So then what's quality gate? Then what does it mean? What does a quality gate mean? So a quality gate, since the quality gate is your most powerful tool to enforce your quality policy, the page starts with project's current quality gate status. If the project passes, a simple green color is shown. And here, so the project. And let me show that. The projects page, and here, this is the quality gate. And here, if it passes, we'll see that green. You see that passed. I just clicked it on, it will show it as a passed. If I click on, if it is a failed one, you'll get it like that. It's failed. Okay. So if not, details and drill downs are immediately available to quickly identify what went wrong. So with a section for each error condition showing what the current project value is and what it should be, as usual, you will be able to click through on current values to get drill downs. So here. Then viewing project measures at a lower level. The project level measures menu item, so you can come here and you to a dedicated subspace where you see all project measures. So choose a measure for more details. Let me click on. Quality profiles and quality gates, and so you'll see that the more information about the instances. Okay, that's fine. Let me put this quality profiles quality. Okay, this is fine. So here we can find out the conditions and then metrics. It's a part of measures only. Okay, so now viewing all issues in a project. The project level issues, I'll click on these issues. So this take you to a project specific page where you can perform all the same actions you can do at the higher level. On this page, issues page, you can easily narrow the list to the new issues as set by your new code definition by seeing the new code in the creation date facet. Okay, let me click on creation date facet. Here you can give start to end date to find out the issues that have been come across, that have been come with the specific source code. Here you can click on that. Okay. And then we have one more, that's a viewing project structure and code. So the project level code and a few more things. Take the viewing project activity and history and using project badges to promote this health. So overall, these are the few more things that you can explore on this section, on this project page that's related to the project page. Okay, so create project and all that information. Now let's deep dive into the quality gates. So what is a quality gate? We know what's a quality gate, but what's the main purpose of quality gate and how can we get more benefit out of it? So a quality gates enforce a quality policy in our organization by answering one question. The first question, is my project ready for a release? To answer this question, you define a set of conditions against which projects are measured. For example, no new blocker issues. So code coverage on new code greater than 80%. So these are the rules we will set up to answer that question. Is my project ready for release? So let's see the definition of quality gates. Let me get into that. Let me show that quality gate permission also, but before that let me show this. Yeah, here is the quality gates and this is the default quality gate and this is the quality gate that I have created. So that's the built-in quality gate and this is the quality gate that I have created. So these are the conditions which are part of that. So this quality gate consists of a defined conditions Ideally, all projects will use the same quality gate, but that's not always practical. For instance, you may find that technological implementation differs from one application to another. uh, Example, you might not require the same code coverage on new code for web or Java applications. That's one example. You want to ensure stronger requirements on some of your applications. So, which is why you can define as many quality gates as you need. So you can access the quality gates basically from this item of the main menu. So let me click on create so that we can create a one more quality gate, and this I'm gonna say quality gate 1. Click on save. So by default, so these are the conditions it got. So let me, you can set as default from here. Yes, now quality gate 1 is set as default, and this consists of these conditions, and all these conditions on new code only. Okay, so quality gate permissions. Now let's see the quality gate permissions. By default, only users with the global administer quality gates permission can edit quality gates. So to set this one, to change that permissions, we have to get into the administration, click on this, then you have to get into the security item of the administration. Inside that you should find a global permissions. Yes, here it is. Now SonarQube also allows user with global administer quality gates permission to give an expert or group of experts permissions to manage a specific quality gate. So here you can see that Sonar administrators and the administer quality gates as well as the quality profiles. And here is the execute analysis and then create project. Now you can give an access administer quality gates access to certain experts also. Okay, so these experts only have permission for the quality gate, not all quality gates. So whichever quality gate you give permission, so for that only they can have. You can see that Sonar users, this is Sonar users, that's Sonar administrators. Every authenticated user automatically belongs to this group, can use these quality gates and then quality profiles, or anyone. This was the previous one. Now it got deprecated. Anybody who browses the application belongs to this group. If authentication is not enforced, assigned permissions also apply. So this is deprecated. Because of this we used to face a lot of issues. Now it's deprecated. That's fantastic. So only gate status, the current status is displayed prominently at the top of the project space. You can see that here. You can see the status of the quality gate, and then you'll get the notification of the quality gate through the, if quality gate fails, you're gonna receive the notification. So how to define a quality gate? That's the next question. To define a quality gate, each quality gate consists of a set of conditions, and each condition, each condition, you can see the condition here. So each condition is a combination of a measure, first one, a comparison operator, you can see that it's a metric, the first one is a metric, it's a measure, and then a comparison operator and an error value. You raise that, an error value. So this is a quality gate condition is made up of. A quality gate condition is made up of three parameters: a metric, an operator, a comparison operator, and a value. So for instance, a condition might be a measure blocker. So let me come here and I'm going to create a new condition. If you want to add a new condition, or you can edit the condition here. So whatever the way, or you just click on unlock editing. it will be open. So grant here from there. We have talked about the permissions right before. So permissions, users with the global administer quality gate permission and those listed below can manage the quality gate, specifically this quality gate. So from here you can access the permissions, and here you have to either administrators admin or Sonar administrators or Sonar users, whichever it may be. Okay, so let's create one more quality gate. So I'd say quality gate 1. Wait, quality gate, or let me say the simple one, QG2. So let me save this, and you got it, the new quality gate, that's QG2. So unlock editing, and here you can find out the add condition. So now, do you want to add condition only to new code or on overall code? I'll go with the new code one. So the first example we want to look is measure blocker issue. These are the measures. So I'll go with the blocker issue. So I have to find out the blocker issue. Let me search the metrics or measures. So blocker issue. You see that these are the blocker issues. Now after that you got the comparison operator, that's is greater than. So I'll go with a 0 value. So then only, so add condition. Okay, so one condition has been added, that's a blocker issues. You see that it's greater than 0. So next I'm going to add one more condition now. So but this time it's on overall code. So overall code, what I'm going to do is let me scroll down, skipped unit tests, skipped. So if it skips at 2 unit tests, that's it, you break the flow. And here you should see conditions on overall code, the skipped unit tests, that's the measure, and operator is greater than, that's a comparison operator, and values 2. So that's what a condition is, and the set of conditions is nothing but a quality gate. Okay, we have seen quality gates, conditions, and various information that's related to the quality gates. But now we will look into the rules. Sonarqube evaluates your source code against its set of rules to generate issues. There are basically 4 types of rules. So code smell and bug, vulnerability, and a security hotspot. So let me show that. Let's get into the, so come to the issues and then go to the rules. Yeah, here is that. Let me scroll down completely, and here is the 4 types of rules. Let me make it bigger. Yeah, 4 types of rules we have, out of which the first one is bug. So bug is nothing but reliability domain. Then we have a code smell. Here code smell, it's a maintainability domain, and we have vulnerability, that's the security domain, and security hotspot, again the security domain. So for code smells and bugs, 0 false positives are expected. At least this is the target, so that developers don't have to wonder if a fix is required or not. For vulnerabilities, the target is to have more than 80% of issues to be true positives. Security hotspot rules draw attention to code that's security sensitive. It's expected that more than 80% of the issues will be quickly resolved as a reviewed after review by a developer. So this rules page is the entry point where you can discover all the existing rules or create new ones based on the provided template. So let's see some of the existing rules. So by default, when entering the top menu item that you can see on the screen now, the rules will be appeared, and you just click on the rules so that you can enter into the rules of that Sonarqube. So now this consists of mainly 5 sections. The sub menu. So let me make it. Yeah, type, and let me bring it down. Yeah, so these are the main items in this sub menu, the sidebar menu. So the first one begins with language. So language, here the language to which a rule applies. So there are almost like around so C, Java, JavaScript, TypeScript, PHP, Python. So these are the languages through for which these specific rules, respective rules will be applied. And after that we have type. So type means, let me click on. So we have bug, vulnerability, code smell, or security hotspot rules. So these are the 4 types of rules that we have for this language specific. Then we have tag. A tag is it's possible to add tags to rules in order to classify them and to help discover and more easily. So now let me click on, see, we found plenty of tags. Oh, CWE pitfall, convention, suspicious, OWASP 8A3 unused. So rejects AWS cert. So it's pretty easy to identify the respective rules. So that's the reason we use a tag. Then we have repository. Repository is the one. So let me, yeah, here is that repository. So we have so many: Sonarqube Java, Sonarqube C hash, Sonarqube JavaScript, TypeScript, PHP. These are the repositories. So the engine or analyzer that contributes rules to Sonarqube, that's where this repository. So Sonarqube Java repository contributes, and this will act as an engine or uh, analyzer to do the respective analysis. And we have default severity. Let me scroll down here. Default severity. So we found some default severity. So the original severity of the rule as defined by the Sonarqube. So these are some: blocker, major, and critical, minor, and info. So these are the some of the major these are the severity of the existing rules. So let me click on blocker. So these are the rules that are blockers of that are related to the Java. I think whichever we have chosen, I do not know. Let me select the language first. So language is here. Let me check Python. That would be easy. It consists of less. So blocker. So Python consists of 41 blockers. What are those? Let me click on blocker again. Yeah. Exit should accept type value and trace back arguments. Underscore init underscore should not return a value. So these are blockers. So what is critical here? So these are the critical rules. So break and continue should not be used outside a loop. If you use it outside a loop, it's a critical bug. It's a very critical bug. You see that? It's a critical bug. Then we have a major bugs. So major bugs, again we have 96. So it should not be used in the test equality. So this symbols. And minor bugs, these are absolutely, it's not absolutely fine. It's somehow, it can be managed. Except clauses should do more than raise the same issue. So pass should not be used needlessly. Then info, so basically to track uses of the to-do tags. So then we have a status here. Let me click on status. So in status, rules can have three different statuses. One is beta. The rule has been recently implemented and we haven't gotten enough feedback from user set. So there may be a false positives or false negatives. So ready, this is not beta 1. Okay. So at this moment, here you can see that beta. So beta is 0. No such rules, no such information now. So the second one we have is a deprecated. Here you can see that the deprecated. The rule should no longer be used because a similar but more powerful accurate rule exists. So when I click on deprecated, there are no such rules inside that. Okay, only beta rules also 0, deprecated also 0. So ready, we have one. So that's in info. Okay, no, beta is 0, but whereas deprecated, we have plenty of rules in Python. So all those rules are deprecated because they have come up with better rules than this. So these deprecated rules for Python 19, it has 19 deprecated rules. Then ready. So the rule is ready to be used in production. That's what the ready. Okay. Then we have available since. So this gives an information date when a rule was first added on Sonarqube. You can select so anything. So that's what the available since. And this is useful to list all the new rules since the list upgrade. Let me select any date, February. So let me clear the screen first. Yeah. Let me clear it. And again, I'm gonna add a February, Jan, anything, third Saturday. Yeah. So that like that you can basically filter your the date the rule was first added. Then template display, here you can see the template display rule templates that allow to create custom rules. Let me click on templates. Okay, show templates only at this moment. So these are the templates, these are the rule templates. You can just click on this and you can extend the descriptions, and based on this template we can create a custom rules. Just click on the create and you start. You write, give the name of the rule, then key and type. This is how you see the type, whether it is a bug type or vulnerability type or code smell type or security hotspot, and severity, whether it is blocker, critical, major or minor or info, and is it ready for the deployment, ready to use, or is it in testing mode or beta. That's called, is it in still testing mode or it's deprecated continuously, and you write the description. So name and then key and description, and just click on create. It will get created. So then one more thing that we have is a quality profile. Here you can say that I'll click on quality profile. So the built-in one, we have Sonarqube Python. So quality profile, inclusion in or exclusion from a specific profile. So if a quality profile is selected, let me click on this. Let me clear this. Yeah. If a quality profile is selected, it's also possible to check for its active severity and whether it is inherited or not. Now let's understand issues better. So while running an analysis, Sonarqube raises an issue every time a piece of code breaks a coding rule. The set of coding rules is defined through the associated quality profile for each language in the project. So let's see, there are three types of issues: a bug, vulnerability, and code smell. And after that, then each issue has one of five severities. That's a blocker and critical and major and minor. So we will look into the each, and first we'll get into this, and I'll go to the issues. And here you can see the three types of main three types of, let me make it bigger. Yeah, three main types of issues. The first one is bug. What is bug? A bug is a coding mistake that can lead to an error or an unexpected behavior at runtime. So that's what we call it as a bug. Then what is vulnerability? A bug, and let me clear the filter. Yeah, and then vulnerability, a point in your code that's open to attack. It provides a way to it provides a backdoor for the hackers or attackers. That's what we call it as a vulnerability. Then we have code smell. Code smell is a maintainability issue that makes your code confusing and difficult to maintain. So that's what the code smell is. Let me clear the screen. So now each issue has one of five severities. One of five severities. What is that? The first one is blocker. So let me click on this. Let me scroll up. Yeah, the first one is blocker. So bug with high probability to impact the behavior of the application in production. Memory leak, unclosed JDBS connection. So the code must be fixed immediately. So that's what the blocker means. When you put the blocker severity to any rule or any issue, so then the code must be immediately fixed. The code must be immediately fixed. Okay, that's what the blocker is. When you get while you testing your source code or test code, if you find some rules or some lines of code with a blocker severity, then you have to act immediately. The code must be fixed immediately. Then we have critical, either a bug with a low probability to impact the behavior of the application in production, or an issue which represents a security flaw, empty catch block, SQL injection. The code must be immediately reviewed first, and based on the impact that it's going to create, based on the influence that it's going to make, so we have to take the decision to be fixed or not. But immediately it should be reviewed. The critical one should immediately be reviewed. Then we have major here. So the quality flaw which can highly impact the developer productivity. Uncovered piece of code, duplicated blocks, unused parameters. So these kind of things are called a major. These kind of things will come up with the major severity. Then minor, again these are also quality flaw. The quality flaw which can slightly impact the developer productivity. Lines should not, example, lines should not be too long. Switch statement should have at least 3 cases. Basically the major, so other than the blocker and critical, the major and minor is just quality of the code, the way you have written. Examples like the lines, how much length of the line you are maintaining, whether you are duplicating the blocks again and again. So whether you are using parameters which are not used, whether you are keeping the parameters inside the code which are not used, whether you are keeping the variables which are not used, whether you are keeping the constants in the code which are not used, and unnecessarily whether you are keeping the spaces, and unnecessarily you are keep making the lot of modules, a lot of blocks. So all these things will lead to the will come under major and minor severity. Then we have info. So info, neither a bug nor a quality flaw, just a finding. It's information. In addition to that, we have few more things here: scope, resolution, status, whether it is main code or test code. That's what the scope. Resolution, whether it is fixed or removed or won't fix or false positive or unresolved. That's the information, that's the action is done or not. That from that we're gonna get it. And the status, whether it is open or confirmed or reopened or resolved and closed. It's like a dashboard, a issues dashboard, where you can see the status of the rule or status of the bug or status of the issue, specifical issue. It could be a bug or vulnerability or code smell. From getting the severity, then seeing the scope, whether it is main code or test code, then looking into the resolution, whether action has been taken, action has been taken or not, and then can find out the status and which security category it belongs to, and more information such as creation date and which language it belongs to, and what kind of rule it is using, and then few more things, that's tag, and then project, and to whom it's assigned, and then author. That's it. Let's wrap up this section after discussing issues life cycle and then various events belongs to Sonarqube. Then we will jump into the project. So issues life cycle, it begins with the statuses. After creation, issues flow through a life cycle, making one of the following statuses. Okay, so either open or confirmed, resolved, reopened, or closed. And then similarly, we can have a issues, we can have a resolutions, fixed or remote, and false positive, and won't fix. So let me get into that, and I'm going to show you one more time. I just gave you the brief understanding. Let me come down. Let's come to the resolution. You have the 4-5 options. The first one is fixed, unresolved, and before that we'll look into the status first. Status, we have 5 statuses. One is open. Open means it's set by Sonarqube on new issues. Then we have confirmed. Confirmed means it will set manually to indicate that this issue is valid. And resolved, set manually to indicate that the next analysis should close this issue. Reopened, set automatically by Sonarqube when a resolved issue hasn't actually been corrected. So closed, automatically it would automatically be done by Sonarqube for automatically created issues. It will automatically close that. Then we have resolutions, such as let me click on the resolution, unresolved, and false positive, fixed, removed, and won't fix. So closed issues will have one of the following resolutions. Fixed, set it's automatically when a subsequent analysis shows that issue has been corrected or the file is no longer available. Then removed, set automatically when the related rule is no longer available. The rule may not be available either because it has been removed from the quality profile or because the underlying plugin has been uninstalled. And resolved issues will have one of the following resolutions, such as false positive or won't fix. So if the issue has been resolved, that can have either false positive or won't fix. False positive means basically it's resolved, it's showing positive, but it's not the case. And then won't fix, so at this moment it's not fixed, and it's at to fix it. That's it. And we have issue workflow, and issues are automatically closed. That's a status closed when an issue has been properly fixed. That's a resolution fixed. An issue no longer exists because the related coding rule has been deactivated or is no longer available. So issues are automatically reopened when an issue that was manually resolved as fixed is shown by subsequent analysis to still exist. So then we will look into the activity and history, or simply there are 4 types of events. The project, so there are 4 types of events mainly. The first one is quality get. It talks about the status of the quality get changed. Then profile, the quality profile used to analyze the project changed. So either the profile was edited or a different profile was issued to analyze the project. Then the version, the project's versions changed, and then an event was manually created on a snapshot. So now so far we have seen the concepts with the practical explanation. So now we will move on to one project. So in the second part of seventh module, we have looked at how to analyze the static code of an application using Sonarqube. This analysis can detect and prevent code syntax problems, vulnerabilities in the code, and also indicate the code coverage provided by unit tests. Then we detail the use of SonarLint, which allows developers to check their code in real time as they write their code. So finally, we looked at the configuration of Sonarqube and its integration into a continuous integration process in a project. So to ensure the continuous analysis that will be triggered at each code commit of a team member. So in the next module, in the next part of this seventh module, we will look at some security practices by performing security tests with the JED attack proxy, JAP tool, executing performance tests with Postman, and launching load tests with AWS. Those are one of the examples which can be combined with JAP. However, I'll see you in performing security tests with JAP.